To start off, before we get into anything else, I had the same question first period, and obviously we're having it again. When is my answer going to be in the restricted to the two quadrants or not? Okay, remember when we started talking about this originally? Okay, if I asked you what is the square root of 9, what is the square root of 9 going to get me? It is not positive and negative 3. It is 3. Okay, the square root of 9 is 3 because of this. If I were to graph square root of x, this is what square root of x looks like. Okay, if I go to 9, right here, there is one answer. It is only 3. Okay, it's only going to cross this one time. If I just graph x equals 9, it's one answer. Okay, because it is the square root. That is different than this, y equals x squared. Okay, and I want to figure out when y is equal to 9, like x squared equals 9. That one has two answers because a parabola goes like that, while a square root graph only goes like that. Or in other words, okay, if the square root sign is already there, if it's like the square root of x and you're doing the square root of 9, that has one answer. It's only 3. But if I'm answering the question, when is x squared equal to 9, the answer is plus or minus 3. Okay, you're technically taking the square root, but it's a different setup. Everybody okay with me onto that point? That leads us to the other thing. Okay, if I were to ask you what is the inverse sign of 1/2, inverse sign of 1/2, that is a different question than when sine of theta equals 1/2. Technically, both of them, you are doing the inverse sign, but the difference is this one's already written. Okay, this answer is going to be forever. This one's only going to be 1. Again, let me show you why. If I were to graph that, if I were to graph inverse sine, so arc sine of x, and I were trying to figure out when x is 1/2, it's only going to have one answer. The only answer to this question is right here, okay, at pi over 6. That is a different question than if I were to ask when is sine going to be 1/2. So then if I asked when y is 1/2, I have a whole bunch of answers. It is pi over 6. Sorry, let me turn this off. Pi over 6. Let me turn that off. Sorry. Pi over 6. And that one. And that one. And that one. And that one. So the difference is I'm restricted to the domain if inverse is written. If I'm just doing the inverse to solve, then I'm not restricted. Does that kind of make sense? It's a weird thing. I know that that's a struggle, but that's what you're trying to do. Okay, let's go over this review. There are your answers 1 through 12. Check your work. See if I can answer anything for you. Looking at 1 through 12, any of those in particular that you need me to work through or explain or anything like that? Yes, ma'am. Will this thing be up during our test? No, the unit circle is not going to be up during the test. You need to do it without a unit circle. On number 7, I'm doing inverse secant of radical 2. So if I want to do inverse secant of radical 2, that is like me asking inverse cosine of 1 over radical 2. 1 over radical 2, oh, I don't like that, so I can multiply top and bottom by radical 2. Oh, it is radical 2 all over 2. Okay, or in other words, when is cosine positive radical 2 over 2? That is going to happen at pi over 4 on my unit circle. Other questions through number 12? There's the next part. Check those. Questions on 13 through 20. Anything on there I can help you work through? Yeah, so the question is on inverse problems, you can always do x, y, r. So if inverse is on the inside like these, you can jump to x, y, r. Okay, so like 20 and 21, technically I don't need to do that. I could think about where the angle is and then do it from there. But if it makes you feel better to do x, y, r when inverse is on the inside, yeah, you can do x, y, r. Okay. Yes, ma'am. We get our calculator. Yeah, because you have to do calculator problems. Questions, other things on the front side? There's the back side. Yes, ma'am. So the two problems that were not on our review, but they're on the answers, we have to know how to. No. Yep. Number 65. Tangent of theta equals radical 3. And so the first thing I did is I subtracted radical 3. Then I'm doing inverse tangent. So I'm looking for everywhere on my unit circle that tangent's going to get me negative radical 3. Think tangent is y over x, so that means I want y to be radical 3, and I want the x to be 1. So I'm thinking about where on my unit circle is that true. It needs to be negative, so it's quadrants 2 and 4. That is 2 pi over 3 and 5 pi over 3. Other questions on 64 through 66? Other questions? Bottom part. Make sure you can graph. Okay, as I walked around, I saw a lot of people without anything graphed or being able to use your calculator at all. So make sure you can use your calculator and solve all those things. Because if you can't use your calculator, it's just a guaranteed 0 on that problem. On number 73, first thing I did here is I noticed I had sine and cosine. So first thing I did is I did a substitution for sine squared. Instead of putting sine squared, I replaced it with 1 minus cosine squared using our Pythagorean identities. Okay, from there, I FOILed or distributed that 4 into both things. That's super ugly looking, but I imagine I could draw arrows. Yeah, right there. So I got 4 minus 4 cosine squared. Then I notice I have a quadratic. I've got a cosine squared and a cosine, so I got everything on the same side. So I moved this over. I moved the 4 over. 1 minus 4, that's where I got this negative 3, and then I have it that way right there. Then I made it u's. So this is 4u squared plus 4u minus 3. I've got to factor that. Okay, I did borrow and payback. I borrowed that 4 to make it negative 12. I factored. I divided by the 4. And then I solved. Cosine is negative 3 halves and cosine is 1 half. Cosine can never be negative 3 halves because cosine is outside of negative 1 and 1. And then when is cosine 1 half? That is at pi over 3 and 5 pi over 3. Other questions on 72 through 83? Yes, ma'am. 80. Inverse cotangent of negative 4. Do you have an inverse cotangent button on your calculator? So what button are we going to use instead? Second, tangent. So we're doing inverse tangent. I want to do inverse tangent at negative 4. So or inverse cotangent at negative 4. So that means I'm doing inverse tangent at negative 1/4. You do the inverse at the reciprocal. So I'm doing inverse tangent at negative 1/4. I hit enter. I get this answer right here, negative 0.244. That is inverse tangent. Inverse tangent lives in quadrants 1 and 4. This answer right here is in quadrant 4, but I'm doing inverse cotangent. Which quadrant do I need it to be in if I'm doing cotangent and it's negative? 1 and 2. So I got to move that thing to 2. So how do I move that angle to quadrant 2? I'm going to add pi to that answer because I need to go 180 degrees over. I add pi to it. I get 2.90. Make sure you can do calculator questions. If you can't, you're going to go in tomorrow and just take an L on all of them. Questions there? Let's go to bell work. We're solving from 0 to 2 pi. I made these a little bit more challenging. They're not that challenging. Okay, just be able to do them. Obviously, the first thing we're going to do here is we're going to add 4 and then divide by 8. So I'm really getting sine of 5/3 x equals 1 half. Once I've done that, Matthew, what can I do next? Inverse sine. I want to get rid of sine, so we're doing inverse sine. So Matthew, when is sine going to get me 1 half? Pi over 6, 5 pi over 6. Which would be great if x were by itself. It's not. I've got a 5/3 in front. What is that 5/3? Tell me about this problem. What does that 5/3 represent? I'm going 5/3 times around. That's awful. Okay, everything about that sounds bad. Okay, I would maybe say, 5/3. It really just means more than 1. Imagine I could write than. More than 1 times around. That's what it means. Okay, is it more than 2 times around? No, 5/3 is less than 2, but it's more than 1. So what does that mean? Well, it means to these two answers, I need to go around again. How do I show that I'm going around again? Add 2 pi. We could get crazy and understand exactly where it is, but I'm just going to add 2 pi. So I'm really going to add 12 pi over 6 to both of these answers. So 12 plus 1 gets me 13 pi over 6. 12 plus 5 gets me 17 pi over 6. But I'm not done. I want to go, what else do I need to do here? I already went around 2/3 times by adding 2 pi. Now what? Yep, get rid of the 5/3 by multiplying by 3/5. So I'm going to multiply everything by 3/5. When I do that, I could simplify because I've got like a 3 and a 6. So that's like a 2, and that's like a 2, and that's like a 2, and that's like a 2 on bottom. I'm just simplifying. So my answer is going to be this. Pi over 10. Those 5s would cancel. So it's really just pi over 2. 13 pi over 10. And 17 pi over 10. That's ugly. Are all of those answers between 0 and 2 pi? Yes, they are. Okay. Yes, they are. They're all between 0 and 2 pi. Understand why. Okay, I'm going to go over to my unit circle. So people at home, tough luck. Okay, a little bit ugly by me putting 5/3, but that's my job, to be ugly and make things hard. Questions here? All right, good deal. Let's go to the second one. So we can do this one a couple different ways, and this kind of leads into what we're doing second semester. Okay, that's why I threw this in here. Normally we would just start second semester on Wednesday, but we're not because of how the schedule goes, so it's different. Thoughts on what we could do first? Let's FOIL, especially since I said like right here, FOIL first. But multiply by 1, boom, 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 boom. 1 times 1 is 1. 1 times secant is secant. -1, or negative secant times 1 is negative secant. And then negative secant times secant is negative secant squared. And that's all equal to -3. Megan C., what can I do next? Okay, so what happens with these two guys? Bye-bye. We could add the 3 over. I'm going to move the 1 over, but you're not wrong to do that. So I get negative secant squared theta equals -4. Everybody good to hear? Okay, I'm going to actually write it like this first just because I can. But it's 1 minus 1, boom, 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 and then we're going to move it over. Negative secant squared theta equals -4. I'll show you why I did that here in a second. But I get that right there. Then what? Jack, what can I do next? Sure, so secant squared theta equals 4, then what? Square root it, square root it. So what am I going to end up with? Secant plus or minus, since I'm taking the square root. When is secant going to get me plus or minus 2? Or in other words, when is cosine going to get me plus or minus 1/2? That's going to get me that at pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All of those 4 answers are my answers there. The other thing we're going to do second semester is this right here. Okay? When you look at this part right here, maybe you recognize this 1 secant squared thing. Okay? You might have forgotten, but remember you had this Pythagorean identity. What would I want to multiply everything by? What would I want to divide everything by if I want it to be secant? X. So we would divide everything by x squared. It would get me 1 plus tangent squared equals secant squared. Or in other words, 1 minus secant squared equals negative tangent squared. And you could substitute in there. Okay, for right here, you could plug in negative tangent squared equals -3, and you could solve it the same way. Okay, you would figure out when tangent of theta equals plus or minus radical 3. And guess, when does tangent of theta equal plus or minus radical 3? The same spots. Okay, it's a weird concept that they go back and forth, but they go back and forth based on what they're given. Questions here?